Today I will talk about running neural networks and mostly LLMs on the edge devices. And by edge devices, I would like to tell that this is very stretched things. You can have very, very different levels of edge devices. Technically, for us, it's everything what we run not in the cloud. Because for cloud, we can have very huge resources, but you need internet and you lose the privacy and pay a lot of money for the inference. Most embedded edge devices are specialized chips like NVIDIA Jetson, Halo 8, which we seen on one of previous meetups, and Qualcomm Snapdragon. You can also add here iPhones and laptops. iPhones are actually really good for running the neural networks because they are highly specialized. And actually, Apple, what we do, we moved a lot of highly fine-tuned models onto the phone and produce very small but specialized tasks. If you do go with running here locally, you get privacy. This is like the thing which we most of us concerned of. One of the benefits will be reduced latency and offline capabilities. You can run without being strictly bounded to be network. And one of other things is cost-effective scaling, because when you have to run something like support for people, and if you have a lot of people who need to support, for example, like millions of customers, to help them with inference, it will be paying cost for you too much. If you can unbound this to customer devices, this will reduce cost from your central servers. But running on edge, as we all know, there are a lot of limitations. You have restricted power processing, restricted energy supply, and memory, most of all. Memory and storage. Storage mostly for size, but memory for inference. Some models are really huge and some are much less than they are. If you take a look on this picture, you will see that not that far ago in the past, transformer models, when we started, they had just like 50 million parameters. Now we have like 500 billion parameters, and they scale it a lot. If you try to run 8 billion parameters model, something like Llama 3 or maybe DeepSeeker, you can do it only on hardware like MacBook M3 or M2 with a lot of memory. So you will need around 16 gigabytes of memory and embedded GPU to make it run. It will be slow with inference time like 5 to 10 tokens per second. But if you choose some models which will be smaller, you can go forward. I will not go deep dive into the scaling models down. I will name the two main techniques which I use now: pruning and quantization. Pruning effectively means that you drop out a lot of, you verify which parts of your model you can drop out to continue to have the required quality of output. This can be like horizontal, vertical pruning. You can fine tune after you prune, after you drop out some parts of some layers, some blocks. Quantizations means that you downscale the weights parameter, like from 32-bit to up to 2-bit and 1-bit. 32-bit floating points operations, they are really hard. If you quantize down your model, realistic one, which you can get, it's 4-bit quantization. Super extreme options are single-bit quantization, and they will effectively allow you to replace multiplications with addition. Effect of scaling models down are quite high, so you can scale down like 20 times and still keep the required level of output. So your results will be still useful and not that bad. You can see that pruning and quantization, they are like quite orthogonal, but technically they mean that if you have a very huge model, you can get the most important part of it and drop out all information which is not required for this model to function. There are many techniques to do it, but to get our main goal, we need to know that we can scale down model and receive useful results. What I would like to present as a more hands-on experience. You have there is text-to-speech model, Whisper. It's presented by OpenAI. Not everything which you get from OpenAI is in cloud. You can use inference from cloud, from API, but we are talking about on edge device, and you can run model which allows you to make speech recognition and translation. So Whisper model it has size from up to 1.5 billion parameters to small 40 million parameters model, the teeny size. Sorry. Locally, you can run everything which can fit into your memory from laptop. But, technically, you can run large, medium. There is also one model which is not mentioned here. It's turbo. It's super optimized large model which has like around 800 million parameters. I tested 3 models, teeny, base, and turbo. They allow you to make to recognize voice and even translate it from multiple languages into English, because Whisper is English centric model. If you want to do some other work, it will be if you want to do not just English, you will need to use other specialized models, but today it's not that. So Alice in Wonderland. Can you hear the sound?
No, can't hear the sound. You're gonna have to, when you share, you need to specify share with sound. You may have to stop sharing and reshare with wrong sound.
Alice was beginning to get very tired of sitting at the bank and of having nothing to do. Once or twice she had peeped into the book her sister was reading, but it had no pictures or conversations in it. And what is the use of a book, thought Alice, without pictures or conversation?
Okay, I hope you've been able to hear this sound. Yes, no? Cool. So this is a very nice text. The voice is very clearly distinguishable. And I run the model to transcribe it, teeny model, English text. And as you see, results are pretty good. So Alice in Wonderland by Lewis Carroll, Chapter 1, Down the Rabbit Hole. I was not able to find any incorrects for this. So to run this model inference, we can try to use it again. So like in Wonderland, turbo. So this is turbo. I would like to use teeny model again to see how good reproducible results are or not that good. As you can see, it took just first 5 seconds, but translation is correct. So inference time for this is more like 5 seconds for this period. If you use a model which is bigger, inference times go much higher. Like 15 seconds, 30 seconds. Scaling down, so you can run 40 million parameters model on the microcontrollers. You can run it on Raspberry. It will be not a direct. It will not achieve currently the translation, which you can get like live translation. But you can translate the voice without internet, and it's useful thing. So as you see, it took almost 40 seconds to translate. I don't know why it shows just first 5 seconds, but previously I got results where all text been output. The more harder complex example will be the French. The one very, very nice song. This is more useful because everyone, most of us know the English, but French is a bit more complicated. I can read it thoroughly, but let's see if it's can get. So Tiny model actually failed to transcribe it in French. Transcribe means just to recognize speech and show the text of it. But if you ask it for translation, it's also we see that Tiny model failed for French. Maybe quality was not that good. I tried bigger model base. It's also got better results like omidab. So it was not the thing which we asked to do. When I used the medium model, which was turbo, it was working perfectly fine with this sound. It's got the correct translation, all words being correct. You can see them here, formidable, formidable, GT, and yes, you can run small speech recognition models offline. It's possible to do, but you have to verify that the model you use it's fast enough for your requirements, and then the resources which you use, if you have resource constraint, you will be resource constraint. You need just to pick up the model which is fine enough for your task. Alice in Wonderland is perfect example to see that Tiny model is 40 million parameters which you can fit inside Raspberry Pi will be perfectly fine. It will be not fast. It will not be fast inference. On Intel MacBook, it took like 5 seconds to generate to this task, but this model is fine-tuned. It's mostly trained. It's trained on like 600,000 hours of text annotated, and it's very good in English. Its main task to be English. So the most important thing which I got from this one, I was able to run it locally, and many models, when you try to run them locally, they really don't run that good. You get a lot of issues, but this one gone fine. If you go into the future, I can predict like in 2 years we'll get the nice offline translation from your mobile phones, like live translation. Not today yet, but with next generations of phones, which will have a lot of neural network hardware, which allow to multiply, to do tensor operations, then you will get really nice results. Questions?
I'm wondering how the training was done, what the training set was. Alice is quite popular material for some purposes, and I'm wondering if the model performs well because it's seeing text that it's familiar with.
Yes. As far as I remember, it was 680K of hours labeled speech data. So, and it's specific. Yes, the text could be Alice in Wonderland. You're right, because I actually tried not just this one. I tried also this one text.
System for this, that once they've detected on it, they'll catch it, they'll paint a coloured dot on it, and then they'll check the time it takes for the marked hornet to return, and from that they can make an estimate of how far away the net.
And actually, if you can see here, this is your text, your voice, which was perfectly fine detected by Whisper with very high quality. So it's not just for text which it's seen before, but also for live voice interactions. And it took like 40 seconds to complete for speech recognition. For this 20-second audio fragment. Also, this model has limitation. It's trained only to recognize 30 seconds batches. If you need longer text, you need to create a batch processing pipeline and put them into one by one.
That's impressive. Thank you.
Any other questions?
I did have a general question about edge computing in the AI world. So the obviously Raspberry Pi has their new AI camera and their AI accelerators. How do you see this working with the central processing? Like, how is all that going to fit together? I don't quite understand how it's all going to fit together.
From my view, I would like to have LLMs running locally, especially coding LLMs as software engineer, to be able to work offline. So for me, it's more like M4 laptop with a lot of computing power would be the best for running locally coding help LLMs like code generation. Edge computing, which we've seen like how 8L, it's possible. It's already running like video recognition, video classification for like 60, 80 FPS today. With better software, you can improve this like twice, maybe 3 times. We got improvement not just in the hardware. We got really huge improvement in the software. Especially quantization, like when I started to dig in, quantization was up to 8-bit. Then like half year ago, 4-bit quantization became like normal for when you get for popular models, and now like 1.5-bit quantization. Technically it's 2-bit, but you can store it in 1.2-bit per. So it allows you to run models with bigger amount of parameters inside the highly restricted hardware. And from my perspective, the more parameters you have, the more knowledge the model has. The quantization, like 2-bit, 4 bits, or 32 bits weights, they provide you more accuracy. but the knowledge is distributed on the network, not on just nodes of it. So yeah, I'm planning to do something like a small robot which will be speaking to me. I can speak to it. It can do some like poem, Shakespeare, like you can call it like Amazon device, but without being connected to Amazon. The most practical approach will be smart home without being connected to network, where you can do all, like, for example, cameras can detect people. If there are any movements, you can detect your cats. For example, if you can train network for your cat and allow door to open just behind your cat. It's possible to do. And it can be done even on like raw Raspberry Pi. For this, you don't need the LLMs. You need just comparison for yours for images. You need to detect exactly your cat, and this is mostly solved problem. So you can train and retrain. You can train the network for cat recognition just for your defined items. Like now you have models which are downloaded to the phone and run locally on phones. They are pretty small, like 200 million million parameters. They can do like Lego detection. So you throw your Lego down, you make a camera, you make a photo of camera, and then you decide which model to build, because it tells where each brick is placed. You need to build like plane or cat or tiger or house.
Any other questions? Okay, thanks a lot, Nick. So,
Thank you.
see where this goes. Thanks very much.